Okay guys, so the first video is going to be here of going over the drill. Hopefully you took the 5-10 minutes or 10 minutes or whatever to try your best on it using your calculator. So we did GCF and we did 3 terms last class, so that's all that this really reviews. So let's look at number 1. Number 1, it's only 2 terms, but you can do a GCF, which is 6. So we put the 6 on the outside, and then that means you divide it out, and then that's going to leave you with x minus 3. And then that's your answer. So factored form means you have this times this. You could check your answer doing distributive property too. Let's look at number 2. Well, this is an x squared, that's a y squared, so you don't have to worry about the letters, but the highest number between 4 and 4 is 4. So you do need to take out the 4, and when I say take out, I do mean divide. So when we divide out by 4, you get 1x squared minus 1y squared. And this is your answer. If we look at number 3, okay, so there are 3 terms. First thing you need to do first is GCF. Now, between 9, 12, and 16, there's no number that'll go into all of them. So we can't do a number, but look at the letters. We can take out a y. No, we can't take out anything, can we? I don't see any numbers there. So this would be prime. Because there's no GCF, and they all don't have a y, they all don't have an x, so this one would be prime. So, okay, let's look at the next one. Here, number 4. Okay, so here GCF. So let's see if these are all to the first power. You can definitely take out an x, a y, and a z. And each of these you can take out a 5, so let's divide by 5, and then an x, y, and z. Because you want to take out, again, the highest number, but then the lowest variable. So in this case, if we divided this by 5x, y, z, it would be 3, and then it would leave you with x squared, y squared, and z squared. I should have made room here. Because then when you divide this by itself, I got to put in a minus 1. You can't just leave nothing there. If there are 2 terms in the problem, in the parentheses after GCF, there has to be 2 terms. So that should be what it says. And that's your final answer. Okay, here, let's start with GCF first. Let's see, 3 obviously goes into all these, so we'll take out the 3. So we'll divide out 3 and get x squared minus 2x. Minus 10. And then now we're going to look to see if we can break this apart with our 2 numbers that add to negative 2 and multiply to 10. Okay, so then let's take a look here. The only 2 numbers are negative 5 and positive 2. Nope. I think that's it, guys. I don't know any 2 numbers because 5 and 2 will make 3. But it won't add up to there, so that's your answer. That one's just a GCF. Okay, so let's try this one. Again, first number is 1, that's why I was doing it. So numbers that add to 5 and multiply to 4. Well, that's just 4 and 1, because 4 times 1 makes 4, 4 plus 1 makes 5, so it's m plus 1 times m plus 4. And there's your answer. Let's take a look at 7. Okay, again, the first number is 1, so you don't have to worry about GCF because I don't see all letters. So same thing, 2 numbers that add to negative 10 and multiply to 24. Well, the only 2 numbers I could think of are 6 and 4, and for them to add to a negative 10, they both have to be negative. So it looks like this in factored form, x minus 6, because you split up that x squared, and x minus 4. You could put the x minus 4 first, doesn't really matter, but. Okay, here, same type, again, there's nothing in front but a 1, so 2 numbers that add to a negative 11 but multiply to negative 42. So that's a little harder. So let's kind of, you can use your calculators. I always try to think, okay, what numbers will multiply to 42, right? So multiply to 42 or 6 times 7. They're not going to make 11. So let's see, 42, 21 times 2. That's not going to work. Here we go, 14 times 3. Again, these are numbers that are going to multiply to 42. And I just use my calculators and try to guess and check numbers. But 14 and 3 will work as long as to add to a negative 11, the 14 must be negative and the 3 must be positive. So my answer is x minus 14 and x plus 3. So let's look at 9. So there's no GCF here. So it looks like, and I'm pretty sure this is supposed to be minus 7x, since it said plus negative, I think. So in this case, we're just going to do the t-chart. So numbers that multiply to 4, let's try 1 and 4. Numbers that multiply to 2, let's make it 2 and 1. So again, you're looking for numbers that multiply to 4, go here. Numbers that multiply to 2, go here. Now again, we're still looking to add, but what add is based on now that we multiply. So 4 times 2 is 8. 1 times 1 is 1. Is there any way that 8 and 1 will add to negative 7? Yes, as long as the 8 is negative and the 1 is positive. Then they will somehow add to negative 7. So how it works again, guys, is since this made the 8, you make this the minus. Since this made the 1, you make this the plus. So that means the 1 will be plus, the 8 will be negative. You always put the x on the left side, and then you draw your parentheses like this to section out your factors. So the first factor on the top is x minus 2. The second factor at the bottom is 4x plus 1. Okay, and here let's try it again because notice there's no GCF between 2, 9, and 18, so I'm going to use my t-chart. So numbers that multiply to 2, 1 times 2. Numbers that multiply to 18, okay, let's try 2 and 9. And then again, this is all just a checking to see if it would work. Our ultimate goal again is still for it to add to negative 9. Okay, so let's try. 2 times 2 is 4. 1 times 9 is 9. Is there any way 4 and 9 will ever add to negative 9? No. So, okay, these numbers don't work. So I cross them off, and let me try to switch the different numbers. So let's try 3 and 6. Okay, and if not, I can always switch the order. So let's try 2 times 3 this way is 6. 1 times 6 is 6. Nope, that's not going to work to make that. Let me try switching that. Put the 6 up here, the 3 down here. 2 times 6 is 12. 1 times 3 is 3. Yes, finally our combination, because as long as the 12 is negative and the 3 is positive, it will add to a negative 9. So finally, what we're going to do is the 2 times the 6 made the 12. Since 12 is supposed to be negative, this will be negative. 1 times 3 made the 3, and 3 is supposed to be positive, so this will be the plus. And you always put your x on the left column, and there are your two factors. So 1x minus 6 times 2x plus 3. Now, even if you come across something on number 11, okay, there's definitely no GCF because there's a 1 in front, but you could still think of, are there two numbers that add to this and multiply to that? So numbers that multiply to 48. So checking on the calculator, I have 16 times 3. That won't make negative 8. 6 times 8. That's not going to work. I got 4 and 12 would be the numbers that would multiply to this and add to this. The only difference is the 12 has to be negative. Well, remember, when you have two variables, the only difference is when you start to put it in this factored form, you start with the x first, like that. Then, because it's two letters, you put the y's here, and then the numbers, the way the numbers should go, just go in front. So since one of the numbers should be positive 4, it would be plus 4 with the y there, and the other number should be negative 12, so it would be minus 12 with the y there. So this is your answer. And here, any GCF? Nope, because it's 3, 5, and 12, so we can do the T-chart. Numbers that multiply again to 3 are 1 times 3. Numbers that multiply to 12, 4 and 3. So let's try 3 and 4, just out of curiosity. It doesn't matter, we could test a guess. And again, we're just going to do what we've been doing. 3 times 3 is 9. 1 times 4 is 4. Is there any way that they will add to 5 in the middle? Yes, as long as the 4 is the negative number and the 9 is the positive, these two will add up to 5 in the middle. So since the 9 was supposed to be positive, we did 3 times 3 to get that. This is the plus. The 4 is negative, so you put the negative here, and you put the x right here. And then you put parentheses like that, and it chunks it. The top factor, x plus 3, and the bottom factor, 3x minus 4. So, after this, guys, you're going to have little notes from me via video on one type of factoring called difference of squares. It works for little guys. And then you're going to be working on a puzzle. It's cut and paste, so there'll be scissors and glue. And it's going to get turned in by the end of class. So, make sure your name's on it. All right, so we're going to do the notes now. We'll give you the notes paper.